One important UI control that you will use again and again while working with iOS is a table view. Now, table view is data-driven control which is present in iOS, and it's used almost everywhere inside any iOS app. And let's go forward and look at some examples. The settings app that probably you're very familiar with using is basically an table view app. And it has got rows of data that is shown on the screen, and then it provides mechanisms for you to actually tap on a given row and navigate out to other screens which can or cannot be table view. Like in this case, when I clicked on journal, I went to another screen, which was another table view. I go and click on about, that's another table view. I click on the next screen. Now this screen doesn't necessarily need to be a table view, but I move out of the settings app. I go to the Apple News app. Doesn't looks anywhere near equivalent to the table view app for the settings app that we had seen, but this app also is a table view app, can be made from a table view app, but you can also make it using card controllers, and that's what Apple may have chosen to do that. But we can also show that and actually create this app and subsections of this app by using table views, and that's what we're going to explore in this section. Before we jump in, let's start looking at what exactly is a table view. Now, as the name would suggest, a table view basically represents a table. That may be different from the perception of tables that you may already have. The reason is, whenever we talk about tables, we generally think about database tables or Excel tables, which can also be represented as database tables, but relational tables, which has a bunch of rows and a bunch of columns. In iOS world, the table view will always have a single column. It will have n number of rows from 0 to n, but it will have only one and only one column. And inside the column, yes, you can have different contents in each and every row. And as you can see, I was giving an example saying that, okay, this particular screen here can theoretically be built using table views. Though not necessarily, Apple probably did not choose to go with table views and probably would have gone forward with card view controllers. But theoretically, it's possible to actually go forward and create this in table view controllers. But when you look at different rows, you'll look at it and say, okay, well, they look so different. Like there's an image in one row, then there's some text in the second row. Then I have got a row which has got two images and two text next to it. So, but you just told me that this can be only one column in the table view. And this is all true because each table view has n number of rows. Each row acts as a container. Inside the container, it holds the UI table view cell. The UI table view cell can have totally different layouts in each and every row, and that's where it actually deviates from your legacy definition of relational tables. Because in relational tables, you're primarily thinking of something which is more like an Excel or a numbers sheet. And in those applications, you will basically end up with equal number of, not equal, basically you end up some n number of rows and n number of columns. But that's the relational structure that they have. But in a table view, which is provided by iOS, each each row has only one column, but each column can have any different variation or any different content in it. So it's not like if the first row had two columns, the second row needs to have two columns, the second row could have just one column. You can start imagining something like, okay, it's more like the first row had two columns, but the second row had a merged column kind of a kind of imagination. That's what you iOS table views are essentially accomplishing. So let's go forward and see an example of the table view in action. I'm going to start with a new Xcode project. I'm just going to call it table view app. And I'm going to go forward and have it created on my desktop itself for now. Now, uh, as with any other application we have developed so far, we have a main storyboard. Inside the main storyboard, we need to add something, and by now you would have guessed it. We are probably going to add a table view. So I'm going to take a table view and add it inside my view controller. I do want to define some constraints for it because I do want it to occupy the entire screen. So I am going to just point out that it's always going to occupy the entire space available or entire safe area. So I have a table view which is now available. It's occupying the entire space. Now it's present inside my main storyboard, and the main storyboard was actually linked to the view controller itself. So it's this particular controller. And if you recall so far, whenever we adding widgets to our storyboard, what we used to do is that where either on click off those widgets, we need to have some actions associated with them, or to access those widgets, we used to define outlets. And we used to define outlets by going to the system view, and then we control drag and drop that particular widget over, and then we'll get an option to create an outlet. Now in table views, you don't necessarily need to do so. And the reason is that just like the UGI picker view, which we had shown in the past, um, the table view actually follows the delegation pattern. So table view adheres to a couple of protocols. One is your table view data source protocol. And the second one is your table view delegate protocol. And it expects that there is a class that implements the methods defined by that particular protocol. And if implemented, it will call upon those methods to get all the information it needs to render the view. You don't necessarily need to tell specifically what is the row refer to the table view and say row one is going to contain that. You will have a method available inside the protocol that you're going to implement, and the method will tell the table view what to do. Let's see in this in action so that it makes a bit more sense. And to add those connections, what we can do is that we can go to the connections inspector, which is the last inspector here. You see we have the data source and we have the delegates. I'm going to use the plus icon here, and now I need to drag and drop the plus icon. After hitting the plus icon, I need to drag and drop somewhere. And I can drag and drop to the view controller here in the document outline, or I can here on the storyboard. Either way, it's going to do the same thing. I'm going to drop it here. So let's see what happened. So I'm going to go back to the view controller and see that okay, now the data source has a hook that has been established to the view controller saying that okay, the view controller implements the UI table view data source. Let's do the same thing for the delegate itself. Let's just hold on for a while because again, let's first cover the differences between the data source and the delegate. The data source will have functions which will be available to do everything with the table view for rendering purposes, like how many rows I should display, what should be the content of those rows, how many sections I'm supposed to display, do I have a header for a section, do I have a footer for a section, and all that is present inside my data source. The delegates is for more granular appearances or for handling actions, like what happens when the user clicks on a particular row inside the table view. And since we are just implementing the table view, we're first going to start with just populating something into the table view, and then we're going to move towards actually going forward and implementing the tab actions. So I'm going to hold on to delegate for now. But just getting some nomenclature out of the way, as you would see inside the settings app, the table view seems to have these sections which are grouped together. Like App Store and Wallet and Pay is supposed to be, looks like it's one group. And then everything else is the other group, and then music and everything goes in different group. Developer is totally different group. They're separated. So is it that there are multiple table views that are present on the settings screen and they're just separated? And the answer to that is no, they are not different table views. And you don't need inside a single page to define multiple table views. These are called different sections within the table view, and you can decide to group those sections out differently. The other thing which you notice is that inside the table view cells, there are some indicators which are present on the right hand side, which is the accessory view. But this is a very common practice which is used in iOS to indicate that this row is tappable. There is a next screen which is available, and that arrow points to next screen saying, tap me so that you go to the next screen. That's called the access review. But this each row, like the music row, is called one UI table view cell. So this is one table view, has multiple sections. Inside the sections, you have multiple rows. Inside each row, you have a single UI table view cell, and the UI table view cell can have multiple different variations inside the settings app. They all have an image and accessory icon on the right hand side, but in a different view, you could go and see different type of layouts altogether. For example, if you look at the Wi-Fi one, then you see that okay, the accessory is actually your table view cell will be different. It has got some right detail on it. Bluetooth has some right detail. Personal hotspot has some right detail on it. And if you look at the name one at the top, then that one looks pretty different. It has got the image icon on it, but at the same point in time, it has got some detailed text after the name as well. And we're going to look into all this now. So far, we have now created our table view. We have mapped it to data source. The data source is mapped to your table view. Now, nothing really changed inside the view controller, and nothing really needs to change in the view controller. That is, you don't specifically need to implement the protocol. Inside the table view, you have linked it. You just need to implement those methods that are defined by your table view data source. But I recommend always implementing the protocol. And the reason is that it makes your code so much easier to actually follow. Plus, you actually code, and you will see is that as soon as I implement the UI table view data source, now it immediately popped me up saying that, well, you did not implement all the required methods defined by UI table view data source. Again, I can always option click. I can see the documentation for UI table view source. I can click on open in developer documentation, and I can read through all the documentation which is available, look at the methods and say, oh, these are the required methods and these are the optional methods, and then go forward and implement it because required ones are marked as required, right? So I can do that, or I can just click upon it and just say fix, and it will go forward and implement the methods that I need to go forward and implement inside my view controller. So let's go with the easy option. I have gone forward and implemented these methods. Now, the number of methods which actually brought up was important method is number of rows in section. Now we talked about the fact that the whole screen is divided into multiple sections, apps to and wallet one section, and passwords, mail, contacts, and so on, but other section. So each section has a certain number of rows, and iOS needs to know how many rows to display in each section. It needs to know that you're supposed to display 2 rows for App Store and Wallet section, and you're supposed to show like 15 odd rows for passwords, mails, and the next section. So let's go forward and do that. For now, I am going to go forward and say that I have 10 odd, or maybe let's just increase the number of size to 15 so that I can see all it occupying the entire screen, 15 all rows. Then the second thing it says is that, okay, fine, there are 15 rows, but you now need to tell me what to show in each row, right? So you need to tell me what's the cell that's supposed to be present in each row. Now, like we said, there's only one column, so there's one cell, which acts as a container. The return type for this one is UI table view cell object. And that's not a big deal. I can go forward and create a constant for UI table view cell. I'm going to start with var, and I'm going to explain why I decided to go with var instead of lat later. And I'm going to say, okay, my cell is UI table view cell. Okay, so I created my cell. Now cell has a property which is called as label, and I am going to use the detailed text label property. Note, like I said, each row has a UI table view cell. The cells can have different types of contents based upon what type of data you are showing. So almost everything inside the cell is of type optional because iOS does not really know which option you will choose, whether you choose the left label style, right label style, subtext style, image, you will have an image inside your table view cell or not. iOS does not know that. So as a result, everything inside is kept optional, and you have to go forward and choose to provide the text. And if you do, then the text is actually displayed. So I'm going to go forward here and I'm going to use string interpolation, and I'm going to say that displaying row number, and I need the row number now. As you see that I don't really know the row number here, but I do have index path. The index path is basically a complex structure which contains two main elements. It has got the section and the row. So imagine we talked about the delegation pattern, and we said is that um, we will have the table view callers. So here we have told the table view that there's going to be 50 rows. One of the first question you will think is that, okay, well, you never told the table view how many sections to display. For example, here there are multiple sections which are available on the screen, but you never told the table view how many sections you displayed. And the reason is that if I do not call that method, and it's an optional method, and if I do not call that method, and I'm going to jump to the definition, and as you will see, there is a method for number of sections, okay, but this is optional. So if I do not call this method or do not implement the method for number of sections, then by default, I is going to assume that I have one and only one section. We're going to start there. We're going to add more sections. Don't worry about it. And we're going to see how it goes. But for now, there's going to be one section, so I did not implement the function. I left it to default to one. Then iOS is going to go and say, okay, well, for section, how many sections there are? By default, there's one. So for the first section, how many rows are there? It comes in here and say number of rows in section and passes me the section number. I totally ignored it because I am not implementing different sections. So I know that there's only one section. I want to show 15 rows in that section. But when it comes to cell for row at that point in time, now IS is asking is that for a section X, for row Y, what do you want to display? So it's supposed to pass me both the section number and the row number. And it does that by wrapping it inside index path. So you can go forward and from the index path, get the row number. Okay. Now, once you're done, you can simply return the cell back to the caller. And that's exactly all that you have to implement. And again, it will complain for now because all it's saying is that, okay, why not define it as a constant? Don't worry about it. Let's keep going forward. Let's go forward and run this on an iPhone 12 simulator. I go forward, simulator. I'm going to disable the breakpoints so that I don't keep getting stopped on the breakpoints. I get this table view, but I am missing the content of each and every row. And the reason is that I accidentally went forward and called upon detailed text label instead of text label. Detailed text label is the additional text that you see below the main text, sometimes inside your cells. So let's go forward and now correct that, and I can see the row numbers basically start from 0. So it's an 0 based index. And I have 15 elements, so it goes from 0 to 14. And I can see all the content on the screen. And it was pretty straightforward, but this is how you go about displaying the contents of the table view on the screen. Now we have talked about examples where there are multiple sections which are displayed on the screen. And for now, we have just one section and displaying all the rows. So let's go forward and look at the example of different sections. And to make it simpler, we have been talking in detail about the settings app, which is provided by iOS. So let's stick to the sections which is exposed by the settings app itself. The first one is the connectivity settings, which is present, where you see a bunch of options, and the options basically include items like your airplane mode. It has your Wi-Fi indicator. It has got your Bluetooth and cellular. This should do for us for now. Now, the second section which we basically get is about notification sounds, do not disturb, and we can call it personal settings. And this will basically say notifications, do not disturb, and it will have screen time option. So we go forward with that one. And the last one will be the journal settings, which tend to have the section for journal for sure, just journal settings, right? So it has a journal section inside it, and it has a control center as well present inside it. So the idea is that now I have got a data source which needs to be grouped differently. So as a result, I went forward and said that, okay, for practical purposes, I may be making a service call and getting all this data, or it could be just some static set of configurations that are available, like for a settings app that's exposed by iOS. Now, since I'm implementing the data source, I have an advantage. I don't need to just know the entire method signature. I can just start typing and do autofill for me. So I want to implement number of sections, and I know this time know the number of sections is supposed to be 3. The catch is now when I'm saying a number of rows for each section, then I don't really know. Okay, it's not always going to be 15. It's going to be a variable number of rows based upon which section it is. So let's forward it. We're supposed to go into this particular order with connectivity settings to the top, or sub settings, and then general settings. And if that's the case, what I can do is that I can switch on section, which information is passed as an argument to my number of rows function call. And then I can go forward and say it's again zero index. So my case 0 is to return connectivity settings dot count. That's the size of my connectivity settings. The second one will be my personal settings dot count. Then my case 2 will be my journal settings dot count. But since it's a switch statement, it does not know that, okay, it's exhausted because the argument passes an integer, not an enum. So I need to have a default clause. I know that this default clause will never be executed because I return number of sections as 3. But the function itself or the language itself does not know. So I need to return something. So I'm going to return 0 if any other section number is passed to it. So now I have divided myself into different sections, which is all good. Now for each section, I'm supposed to show different content. And that one is done using self row at index, which we know very well now. And I have the table view cell, which is getting created here. But what I need to do is cell label it correctly. So let's go forward and write another switch statement. I'm still going to switch on the section. Okay, so I need to know which section I am on. And then if I am on section 0, which is the connectivity settings section, then I'm going to simply go forward and set the label as something which is relevant to the connectivity settings. And for now, all I need to do is to actually go forward and display the content which is present at a given index, the index being the row number. So how do I know which row number I am on? Now, here I had the number of sections. Okay. Here, while I needed to find out the number of rows in each section, the table passed me the argument, which is which section it wants to know the number of rows for, and I return back the number of rows. Now, when it needs cell for a given row, it needs to pass me both the section as well as the row number, and it does so by passing me this complex data structure called index path. And index path has section and row inside it. So when I'm switching here, first of all section, I will say index path dot section. So I get my section. And similarly, when I'm retrieving the values from connectivity settings, I'm going to say connectivity index dot row, and that will take care of it. Uh, the section and the rows are also zero index based, and the arrays are also zero index based, so I don't need to worry about incrementing or decrementing in either direction. Now I'm going to correct this. Give me just 1 second. I'm going to list down all the cases so that we are covered. Now the catch here is again, because it's an integer, so it doesn't know, so there it can be any possible value. So I have to return something. So I'm gonna try and return, oh, I don't even need to return anything because I have a cell object which is created at the top. So I'm going to simply go forward and return that particular, can return the cell object. And here I just need to put a default condition um, to match my switch statement. And I need to pass some text here. Okay, this should never be seen. Okay, and in here I'm going to change it to personal settings. In here I am going to change it to general settings. All good. Let's hit the play button, see what happens. And if we have done it right, everything will show up. So I can see airplane mode, Wi-Fi, Bluetooth, cellular, notification, do not disturb screen time, general control center. So it got displayed. But it looks like a single table view still. And you'll ask me is that, didn't you just show me the settings app and it has got these separators to clearly mark out the fact that there are different sections which are present? So yes, and the answer to that is we have been using the term groups, and we're saying that the whole content is actually grouped into different sections. And that's what we need to tell the table view itself. And inside the table view, you have a style which is defined as plain. Instead of that, choose the value grouped. So say that, okay, you want to group the content which is displayed across different sections as different groups rather than just combining everything into one big table. And if you choose that, you will see that immediately inside your UI, the airplane Wi-Fi Bluetooth cellular is defined as one group. And you can see there's a full cross-line rows which are present at the top and the bottom. And the individual rows inside the group are separated by lines, but that do not go till the end. There's some space which is left. So there are three groups that you can see, which are three different sections. Let's even go further and use some other functions which are available inside your table view data source that we have not talked about yet. For example, when we are going forward and defining the number of sections, we will want to define a title for each header in the section. So we can start again saying, I want to define a title for header in section. And if I do, all I need to return is an appropriate title for the section. And the section number is actually passed to me again. So I'm going to go forward, copy paste this for now. So I don't have to write a switch statement again. But instead of returning an integer, I need to return a string. And for case 0, I am going to say connectivity settings. And for second case, I'm going to say personal settings. And then I'm going to go forward and say general settings. And for the last one, well, it doesn't matter. I'm not really for practical purposes, I would not advise that you need to actually go forward and right does not matter. You can simply return nil. It's an optional which is expecting anyways, but this is just for demonstration purposes. Now you can see you have different sections grouped separately, and you also have a title which has been added for each and every section which is out there. And now there's multiple variations which we're going to talk now, what all you can do within your cell. But before that, you can even have a footer section which can be included for each and every group. You may or may not want to have it, and a lot of apps do not have it unless there's some sort of a disclaimer that you really want to add. That's when you actually go forward and add those footers. So if you really want to add a footer, then you can go forward and say title for footer in section. Of course, you will have the option to autofill it. Let us say only for connectivity setting, I'm going to go forward and define a footer and say something like, oops, I didn't have a switch statement, so pardon me. I'm going to say that if section equals 0, practically I would advise you to use enums, right? Define the enums and then use those enums. But since we do not have the enums, I'm going to go forward with this and say if section equals 0, Then go forward and define a footer, which basically says is something like this section lists all the connectivity options and you can choose its settings. And let's assume that for everything else you just want to return that. Now you could have simply gone with the case and put a default as well and return null in there. Totally doable. It just whatever preference you may have. But again, now you can see that okay, that's how it works. You now have a footer which is present on the first section, which lists down some additional information for the user to actually go forward and see. Now we have a table view which is being shown nicely. It has got different sections, it's got different rows. Now let's add some action. What we want to do is mostly what we see anywhere in the iOS app. You see a table view, you probably can just tap upon it, click upon it, and see more content. And that's what you have been seeing all along with the settings app. Now for doing that, initially I talked about the UI table view data source, and I talked about the fact that it's all for telling what type of data and how to display the data, number of section, title for section, footer for section, and then number of rows for the content for those rows to be displayed. And we talked about all that in great detail. Now, what we want to focus upon is how to actually uh, have handle interactions with the table view. What happens when the user tap on a particular row? And for that one, we have a totally different protocol that we need to implement, and that's encapsulated by the UI table view delegate protocol. Now, even if I go forward and implement the methods in UI table view delegate here, nothing really will happen. And the reason is, if you have not forgotten, I need to provide the linkage, which is when I select the table view inside my connections inspector, I need to go forward and define my outlets. And the outlet which I need to tell is the delegate is going to be handled by my view controller. And once I've added this outlet, now my controller's appropriate method will get called. But unlike your table view data source, where as soon as you implemented the protocol, you started seeing some compilation errors saying you didn't implement some required methods, that's because there were some required methods. The UI table view delegate, and if you actually decide to option click upon it and then open developer documentation, you'll find that it has no required method. It's got a lot of methods which are available, so you can configure a lot of stuff, but nothing is really required. And as a result, you don't really see any error as soon as they go forward and implement it. But for actually implementing a click action, the method I want to implement is did select row at index path. Now, thanks to the fact that I have implemented the particular protocol, I can use the autocomplete feature and it immediately goes forward and shows me the entire method declaration. Now, I can do the same logic that I have been doing all along till now, which is I can have a switch statement. I can check upon the section. Again, I have been passed the index path as an argument. So I can go forward and simply choose to get a section and the row information out of this, and then do different action for each and every row. That's doable. For now, since I'm just demonstrating that, okay, how to implement click actions, where as soon as you click upon it, this function is going to get called, and I'm just going to show an alert pop-up for now to demonstrate the click functionality. So let's go forward and implement an alert. And I'm going to start with a constant. It's going to be of type UI alert controller. And among the initializers which are available, I'm going to use the one which has title and a message. And title is you clicked. Message is what did you click? You clicked row number, and again index path has the row number which is available, so I'm going to use the index path row number increment by 1 because the index path and the row numbers are 0 indexed of section number. Again, I'm going to go to index path dot section incremented by 1, and preferred style is the enum, as you can see. Since it's an enum, you can just use the dot operator, and the two options, you can just use an action sheet which comes from the bottom, or an alert which comes like a pop-up on the screen. I'm just going to go forward with action sheet. So I got my alert. Now I need to dismiss this alert, and for that I can add actions, and the actions are of type UI alert action. And for this, I'm going to use a constructor which has a title, and the title is going to simply say close me, and the style is going to descriptive style because I'm intend to close it, and the handler is going to be null. And I am going to simply go forward and display it present, and the controller I want to present is the alert controller, and that's the alert instance that I'm going to pass in here. I do want this to be animated as defined by iOS, and I really don't want to do anything for completion purposes. So I went forward, and the main storyboard added the connection, which is now pointing out that the view controller is going to be the delegate, is going to have the delegate. I implemented the delegate to a delegation pattern, and then I went forward and wrote some implementation which is going to show an alert for now. Let's go forward and run it, and let's see what happens. It's launching up. I see different sections, all the content is actually displayed now, but at the same point in time, if I click upon any of the sections, now I can clearly see that, okay, this alert which is actually displayed. So the action is actually taking place. This method or this block of code is getting executed. It's saying that you click to number 3 of section 1, and I can close it. I can move on to different ones as I go and test it out. So totally doable, and it's implemented out with row and section numbers. So this is how you go about implementing it. You have already seen our videos on how to actually go about and achieve navigation in the iOS apps. So essentially, instead of actually going forward and just showing an alert, you can actually show a totally new controller, totally new screen, even a different storyboard inside your iOS app. Now, in the next video, we're just going to cover a very important topic about memory management. And you should start thinking about what happens when I go and create those massive table views. And we'll talk in detail in our next video.